Okay, so the last thing that I want to do tonight is to walk you through a Monte Carlo analysis. We'll use the same spreadsheet, same scenario, but let's talk a little bit about what a Monte Carlo analysis is, or a Monte Carlo simulation. So when you use a Monte Carlo simulation, whenever you want to do a risk analysis by building models of possible results by substituting a range of values. So when we do our projections, usually we make our assumptions and they're just static. We say it's 1,600 scans, or it's 10% or 50% of reimbursement. And, we hope that we're right, but there's times that we just don't know. And so what we might want to do is to be able to run this kind of simulation where we can calculate results over and over and over again. We can tell Excel, okay, well, let's take this one variable and we'll set it up as a probability. So instead of saying that, well, reimbursements for sure 50%, because we know we weren't for sure, right? We could say, well, we think it'll be 50%, but we'll use that as our mean, but our standard deviation will be 20% on either side. We can tell Excel to recalculate our NPV, any number of times. So in the example I'm going to show for you today, and we'll have Excel calculated 1,000 times for us. And so after you calculate it 1,000 times, then what is the mean of that set? And what is the minimum and the maximum, which gives you kind of a different look with a little more certainty at your, a little more certainty with your data. So again, this is not something most of you will ever need to be able to replicate. It is kind of fun to understand it and to look at it. And then to be able to play with a little bit. Finance departments, when they do this, they tend to have programs. Crystal Ball is a popular one that they have, and they can just input data and it happens automatically. So, I mainly show you this just for the fun of it. All right, let me share my screen. And let's just do this. All right. Same Excel spreadsheet that we've been looking at. I've made a couple of changes to it. So here on the percent reimbursement, let me put 50% to start with. So we've always had it as 50%. Now I want to say, well, what if I don't want, I'm not sure it's 50%, and sure I can do a scenario analysis, but rather than doing that, what I would like to do is to look at a normal distribution of that 50% and say, well, let's do standard deviation 20%. So, here is our, normal curve. And we know that here within one standard deviation, or these first sets of lines, 68% of our, possible results will fall in there. So that means for, a 50% mean with 20% standard deviation, we're saying anywhere from 30 to 70, right? Percent. So what does that look like? And then we feel pretty confident with our results. So the only thing I've added in the assumptions is the standard deviation. Now I have made a change here on this part of our spreadsheet. So you can see I've got our research volume reimbursed, same formula as before. Patient reimbursed, I now have actually told Excel, do a normal distribution on here. And this is, again, just an Excel function. And see, let me see if I can move this so you can see. So what I've said is do a normal distribution, 50% is my mean, 20% is my standard deviation. And so every time that I hit enter, it's going to recalculate this. So instead of this saying 50% all the way across the way it did, in our previous model, you can see it's changing it, every time. And actually, any change I make on the spreadsheet, Excel will recalculate it and these numbers will change. Now, what can happen, it doesn't look like it happened to us this time, is you can end up with, this being 0 or 100, and numbers that you don't think are probably very likely. And so we truncate the numbers. One, we make sure that they're not going to go negative. And then sometimes we might say, well, we want to be inside this range. And in this case, what we said is, this if statement, if then statement, if this number that's randomly generated is less than 20, then make it 20. If it's higher than 90, make it 90. And then and that just makes sure that we have numbers that we can work with, right? And so you can see it just recalculated, right? And so we'll actually end up using this truncated number as our number that we'll use. And so our income statement is built just the way we've had it before. That's the only difference, is that now we've normally distributed this number. We have our discounted cash flows. We have our NPV. And you can see our NPVs are really different than they were before, right? And that's because these numbers, like here we've got a 77%, 67, 63. A lot of these are over the 50%, which is driving this number higher. But what we want to do is say, well, all right, well, what does that look like if we do this 1,000 times? And so what we want to do here, we're going to come here. This is really amazingly easy. So we're going to do 1,000 observations. So let's come here. I've put 1 as my first observation number. And then we're going to have Excel automatically count it all down for us. So I'm going to go switch, on our home tab, go to this editing, which is not where you would think it is, but it is. So editing, and you want fill, or this little folder with the down arrow. So click on fill, and we want to fill a series, which just means that, 1, 2, 3, 4, 5. So click series. We want it to be linear. We want it to be in a column, because I actually want my numbers to go straight down and not across, because I don't want that many columns. So we're going to change this columns, linear, start with 1, stop with 1,000. And then we're going to hit OK. And look, Excel created 1 to 1,000 for us. Super useful little trick. All right. So now what we want is for Excel to calculate this over for us. We're going to do the first line in NPV. We make it equal our NPV. Oh, look, see, it recalculated again. Every time I hit a number, it's going to recalculate. Okay, so now I've got my NPV here. And now what we want is for Excel to recalculate this 1,000 times. So we're going to do a data table, big surprise. And we want to go all the way down to 1,000. So this seems like it's going to take forever if I just go down arrow, down arrow. So let me show you a shortcut. Just go to your first cell, hit Shift, your right arrow key to highlight both of those 2 cells. And then if you want to hit Command or Control in the down arrow, it takes you all the way to your last entered value, right? So that's good. Now we have 1 through 1,000 all highlighted. Now we're just going to do a data table. All right, ready? So we're going to go data, what if, data table. Now in this case, we don't have a row because these numbers don't mean anything. The only thing we have is the column, right? And our column is this NPV number that we've entered. And let's hit OK. I didn't like that. Let's do, why is that not valid? Equals, what if I do the NPV number up here? And let's see, give it a second. So that didn't work. Oh, I know what I did wrong. Okay, let's do it again. This might be tricky. Let me see if I can delete this. Okay, good, I could. All right, so we're gonna do it again. Sorry about that. Shift, arrow key over, shift, command down. I like to see the top, so I'm gonna go back up to the top. And then we're gonna go data, what if, data table. Again, we don't have input. Our column, my mistake is it should be this right here. See where my cursor is? It's this NPV at 6%. Okay. There, and it calculated it. Oh, it's still calculating. It takes a little bit of time because it's literally running through that entire calculation 1,000 times. So now that we have it, what do we do with it, right? Huge range of numbers. Some of them are negative, some of them are really positive. But what this does is it gives us 1,000 impressions, and now we can do something with it statistically, right? So what I've said is the number of samples, we have 1,000. Take the mean of the samples and all, using the Excel average or mean function. So it's just average. Actually, I'll show you how to do this. So again, just to go fast, you go average, open the parens, start with number one, click on it, and then don't forget, you go shift, command, down arrow, and it highlights the whole thing, end your parens, and then enter. Okay, so that gave us our mean, 584. And then your standard deviation, same thing, use your standard deviation function, and then just highlight this whole column. And then I like to see the minimum and the maximum, same. Minimum function is min, highlight all of these numbers, close parens, and then max is the same. And so then now what we have is we can say, all right, well, our NPV is positive 584,000. That's pretty good. But our standard deviation is 1.1 million. So we've got this huge dispersion, which we knew actually, if you think about it intuitively from this scenario analysis. But this lets you see even in more detail, or more specifically, how wide that dispersion is. And so in these 1,000 samples, the minimum was a negative NPV of 2.8 and a positive of 4.0. Huge, right? So if you look at this investment, you're going to say, that is so freaking risky. There's no way I'm going to do this. It is basically a coin toss of whether or not you're going to have a positive NPV or not. So I hope that this makes sense. Again, you'll never have to do it. It is kind of fun to play with. Use the spreadsheet, try to duplicate it, play with it a little bit. If you run into a problem, don't worry, just do it again. You saw I made a mistake and it's fine. You just stop, try and figure out what you've done, and then do it again. And then just play this video back and forth until you're able to get it all. So anyway, that is a Monte Carlo simulation. Have a great night.